The main goal of this lesson is to solve linear systems or systems of linear equations like this one, using matrices. We can solve this system by using our good old elimination method, so why use matrices? You will see later that using matrices are more efficient because we have some sort of algorithm when we solve linear systems, and would be super helpful, especially if there are several variables. The first concept to achieve this goal is to write the linear system into matrix notation or matrix form. Let us take the matrix A as this 3 by 3 matrix and B as this 3 by 1 matrix. We call the matrix A as the coefficient matrix of our system of linear equations. It is called coefficient matrix clearly because the entries of this matrix A are the coefficients in this system on the left-hand side. Also, let us define the matrix X as the 3 by 1 matrix x sub 1, x sub 2, and x sub 3. Now let us get the product AX. We'll just write the matrices A, B, and X here. This is our system. And let us solve for AX. The matrix A is size 3 by 3 and X is size 3 by 1. So the product AX is a matrix of size 3 by 1. Remember, matrix multiplication is not entry-wise. So to multiply, get the row 1 and column 1. Well, there's only one column in X. Then let's get the product of corresponding entries. That is 1. The corresponding entries are, so here in the row 1, we have the first entry times the first entry of the column, 1 times x sub 1, plus 2 times x sub 2, then plus 3 times x sub 3. And do this with the second row. Do the same. We have 2x sub 1 minus 3x sub 2 plus 2x sub 3. And also for the third row, we have 3x sub 1 plus 1 times x sub 2 minus 1 times x sub 3. Okay, observe that the entries on each row of this matrix AX is the left-hand side of each equation in our system of linear equations. And in our linear system, we want this left-hand side to be equal to the right-hand side. So if we write as matrices, we want this AX to be equal to the matrix B. We want AX to be equal to B. Therefore, this system of linear equations is equivalent to this equation of matrices. However, for us to solve the values for x1, x2, and x3, instead of writing it as the equation AX is equal to B, we write it as one matrix of this form. We call this the augmented matrix of our system of linear equations. The left part of this matrix is the coefficient matrix A. That is the coefficients in the left-hand side of our system. And the right part is the matrix B. That is the right part of our system. Coefficients on the right part. Now let's take an example. Write the augmented matrix of this system of linear equations. Be careful in writing the coefficients. The variables must be in order, so you can also think of this system as like this one. The coefficient of the variables not present in the equation is 0. So for example, in our second equation, we don't have x sub 2 and x sub 4. That's why here, our coefficient for x sub 2 is 0, and same with x sub 4. Similarly, in the third equation, there is no x sub 3 here, so the coefficient of x sub 3 in the second system is 0. That's equivalent. And now that the coefficients are in order, or we can clearly see what are the coefficients, then this is the corresponding augmented matrix. As an exercise, write the augmented matrix of this system of linear equations. Again, be careful in writing the coefficients. The variables must be in order. And write 0 whenever the variable is not present in our equation. And for number 2, do the vice versa. Write the system of linear equations whose augmented matrix is given by this matrix.